2-year-old Darren is playing with a train set that has an engine and detachable train cars. The letters are glued to the engine of the cars, and the two cars' letters are identical. Darren does not know how to spell his name, but he knows that the engine with the letter D must be in front. The total number of different possible arrangements of all the train cars with the engine in front is. So the D is in front, so we don't have to worry about the D at all, because that's fixed. So to use the fundamental counting principle, we start by saying we have 1, 2, 3, 4, 5 letters that have to be arranged. So that's 5 factorial. We'll start with that, 5 factorial. And we know that 2 of the letters are the same. So whether we have the first R before the second R or the second R before the first R, when we switch them around, it's the same combination. So we don't need to duplicate that. So we have to take that into account. We divide by, there's 2 that are identical, so that's 2 factorial. Punch that into the calculator and you'll get, it'd be 120 divided by 260, yeah. Moving on, the diagram below shows a website seating chart for an aircraft. The seats shaded black have been reserved for the lighter shaded seats are available. And the lighter shaded seats are available. There are 12 seats available at this time. 7 customers are each booking 1 seat, and the number of different ways that they could be assigned the seat is available. We know that we have 12 seats available to be filled, and there are 7 customers to fill them. 1 customer each seat. So of the 12 seats, we're going to choose 7 of them. And then within those 7 seats, the order does matter. And the reason the order matters is because we're being asked for the number of different ways that the seats could be assigned to the customers. So 12 seats, you choose 7, and then the order does matter. Therefore, the answer is 12P7. But another way of talking this through is to say that the first customer has 12 seats to choose from, so that's 12. The next customer there's 11 remaining, so 11 different choices. And the next 10, and then 9, then 8, then 7, then 6. So what that is 12 times 11 times 10 times 9 times 8 times 7 times 6 is 12 factorial divided by 5 factorial, which is the same as (12p7). Now, just as an extra note here, if they had said that the arrangements don't matter and they just want to know which 7 seats are going to have passengers in them, and it didn't matter which passenger was in which seat, then that would be different. That would be 12C7. But that's not what they asked us for. They asked us for the number of different arrangements. So that's 12P7.